Okay, so today we are jumping to section 8.1 and we're going to take one theorem from 8.1 and intertwine that into this unit because we think it pertains to this unit because it is talking about similarity in right triangles. So you can see here I've drawn a right triangle, triangle XYZ, and if I took this right triangle, so here's the right angle up here, which means if we were to label this parts of the right angle, XY is a leg of the right angle, YZ is a leg of the right angle, and then of course XZ right here is the hypotenuse of this right triangle. Right? So remember XZ, this is called the hypotenuse because it's opposite the right angle. Okay, well, what do we call YZ right here? So this YZ, I drew it in already, and you have to trust me that this forms a right angle. Well, if I go from a vertex to a side opposite and I form a right angle, then what did I just create? Well, I created the altitude of that right triangle. But most specifically, I drew the altitude to the hypotenuse of this right triangle. So let's say my original right triangle was like this. Okay, then to draw an altitude to the hypotenuse, well, this is the hypotenuse right here, this longest side, right? So I'll do that in red. This is my hypotenuse. And my altitude would have to go from this vertex to here and intersect at 90 degrees. So that would be the altitude. So I can put the right triangle on its hypotenuse. I can have the hypotenuse going this direction, or I could go the other direction. But regardless, I have a right triangle. When you have a right triangle, the longest side is called the hypotenuse, and it's the side that's opposite the right angle. So if you notice, though, when I draw this right triangle, and I draw an altitude in the right triangle, well, this altitude splits this large right triangle into two smaller right triangles. So we actually have the smallest right triangle here, the medium right triangle here, and the largest right triangle here. So let's pretend that I name this angle and I measure it and I say, well, this angle is, actually let's make this angle 50 degrees. Okay, so let's say this angle right here is 50 degrees. So angle YXW. Well, if this angle right here is 50 degrees, then what would, and this angle up here is 90 degrees, what would angle YZW be? Well, hopefully you remember from first semester, the triangle sum theorem would tell you that this angle over here is 40 degrees, because the sum of the three angles of a triangle must add up to 180. So now what we're going to do is we're going to look at these three triangles. So I'm going to redraw these three triangles separately beside each other, and we're going to compare them. So the smallest right triangle, oops, that looks kind of funny. So the smallest right triangle, I'm going to put it in green, and I have the X over here, I have the right angle here, which means the W is here and the Y is here. So this is 50 degrees. Well, if this is 50 degrees and this is 90 degrees, what does this angle have to be up here? Again, because of the triangle sum theorem, this angle now has to be 40 degrees. So this angle up here is 40 degrees. Okay, well, let's do the medium triangle in pink. Okay, so this is my medium triangle. So I'm going to line up my medium triangle to be in a similar shape as this one. So I'm going to put the shortest leg across the bottom. I'm going to draw the tallest leg up and then the hypotenuse. Okay, so what letters would I have? Well, here's my right angle, and the letter at the right angle of this medium pink triangle is still the letter W. But my short leg is right here, so at the end of the short leg is my letter Y, and my long leg is here, WZ. And then, of course, the hypotenuse is opposite this right angle, so my hypotenuse is YZ. So over here I can see angle WZY. So WZY is 40 degrees, so this is my 40-degree angle. But again, because of the triangle sum theorem, we know that this angle over here is 50 degrees. So what do you notice about the small triangle and the medium triangle? So here's my small right triangle, my medium right triangle. They must be similar to each other because of angle, angle, or angle, angle, or angle, angle. Well, if you then compare your largest triangle So let's do that over here. I'm going to use the color blue. Get rid of this real quick. So here's my color blue. So I have my largest triangle, and I'm going to draw it in the same way. So my largest triangle, I have my right angle right here. So here's my right angle I'm referring to, which is letter Y. And then I have my shorter leg, which is X. And I have my hypotenuse, which is XZ. So this is going to be a Z up here. And so then, if I look at this angle X, it's 50 degrees. And this angle Z is 40 degrees because that's what I predetermined to begin with. So what do you notice about these three triangles? They are similar to each other, which means their sides are in the same proportion. Okay, now that you've listened to that, go back to this and take a minute and try to fill in these blanks. So hopefully after watching that first part of the video, you were able to fill this in. It says, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So remember then we had these two triangles are similar to the original triangle, which was here, and they are also similar to each other. So in other words, when you draw an altitude to the hypotenuse of a right triangle, you have three triangles now, and all three of those triangles are similar to each other. So we're going to use that information to then fill in these missing blanks. So I would recommend that you go ahead and pause and try to do questions 1 through 4. You can even move on and try 5 through 8, but I will take you through 5, 6, or 7 so we can go through those together. Okay, so going through questions 1 through 4, again, looking at these, this is the altitude drawn to the hypotenuse, so we have 3 similar triangles. I drew them out here. So the small triangle is SUT. So S is up here at the top, U is my right angle, T is over here creating the rest of the hypotenuse. And that's going to be similar to triangle RUS. So again, this is the longer leg, shorter leg hypotenuse. So here's my longer leg, RU. U is at the right angle right here. And then we have the shorter leg, US, and then my hypotenuse, which is RS. And then here, we have our largest triangle, which is RS is my longer leg, ST is my shorter leg, and RT is my hypotenuse. So once you lay it out, then maybe it's really easy to answer these questions. Or doing the triangle sum theorem, you should have been able to answer these questions really easily. So if angle R is 30 degrees, what is the measure of RSU? Well, because of the triangle sum theorem, this would be 60 degrees. What would the measure of TSU be? Well, if this is 30 degrees, then angle T has to be 60 degrees because of the triangle sum theorem right here. So therefore, this has to be 30 degrees because now this small triangle has to add up to 180. So then if for anything, that's going to work. So if we put the letter K here, well, how are we getting the measure of angle RSU? We're just subtracting K from 90 degrees because these two must have a sum of 90 if it's a right triangle. And then what will TSU be? Well, it'll be the same as whatever R is because of the fact that these two are the same, right? Because if this is 30 degrees, how do we get this one? We have to subtract it from 90 because in this right triangle, this is 90 degrees and these two have to add up to 90 degrees. So it's 90 minus K here and here and just K here. Now, did you get the order of your letters correct here? So if I had RST right here, well, that's going to be similar to SUT, which is going to be similar to RUS. And you could figure that out based on angle, if I put in all the angles in here. Okay, and then if I just decided to reverse the letters, if I put RSU, well, then I would have to do STU, and then I'd have to do RTS. And so it's just the same 3 triangles, but I just rearranged the letters, making sure you understand that the order of the letters is very important. It's what tells you which sides are corresponding to each other, which angles are corresponding to each other. As soon as you know that similarity statement, it's really easy to set up your proportions. So now I'm giving you measures. And I say if SU is equal to 4 and RU is equal to 8, let's find TU. We'll use any of these 2 triangles which relate these to each other. So I see an SU here and an RU here. So first and last letter, SU, is to RU, first and last letter, as TU, which is the third and fourth letter, back to this triangle again. So X, we don't know that, is to, well, we have to use these two letters here because they're the last two letters, so that's to US. So that's going to be 4 again. So it's SU is to RU as TU is once again to SU. So these happen to be the same number. Look at your triangles and verify that. SU is to RU as TU is to SU. This right here is the same as that. So now what do? We just do our cross products. 4 times 4 is 16. 8 times x is 8x. We divide each side by 8. So what does x equal? X equals 2. Therefore, TU has a value of 2. So now go ahead and pause and try the other ones, perhaps. So go ahead and pause and try the other ones. Okay, let's see how you did. So we have TU, we have UR, and we have SU. So TU is right here, so that's my 3. UR is right here. Okay, well these clearly are not in the same location, so they're not proportional to each other, but then let's look at SU. So TU is in proportion with SU, and then RU is in proportion with SU over here. So we can say TU is to SU as, TU is to SU as SU is to RU, and RU is UR, which is 6. So instead of having SU here, we could just put X, right? Or we could put SU, that's fine. So now when we do our cross product, we go 3 times 6, which is 18. X times x is x squared. Well, how do we solve for this if we have a quadratic? This is x squared. Well, what do we do to both sides? We take the square root. So just leave it. X equals the square root of 18. Okay, you can leave it as the square root of 18. You can punch that into your calculator. If you have a TI Inspire, it's going to give you 3 root 2 as an answer in the end. If you do second enter, it's going to give you the decimal equivalent. So any of those answers, you need to double check with your math teacher. I'm not sure we've decided if we're going to want you to keep it in radical form or we're going to want you to put it in decimal form. But right now, I think either of these answers will be fine. And your calculator should do this for you. If you take the square root of 18, it's going to give you 3 root 2. If you have a TI-84 or something else, well, it's going to give you a decimal answer. Okay, let's do number 7. Okay, I find a little typo, but I fixed it for you guys, but this should be SU on your worksheet. If it's not, you need to fix it. Okay, number 7, it says if TU equals 3, so TU is right here. Oops. Whoops, eh? If TU is 3 and RU is 9, then we need to find SU. So here is my TU, RU, SU, SU. So you can see that we're comparing long side to short side, long side to short side. So SU, which is unknown, so TU is short side is to short side, which is SU, as long side, which is RU, is to short side. Oops, made a mistake here. Let me go back to that. Okay, TU is short side, so this needs to be short side over here, which is SU, and then long side is RU, which is 9. We do our cross multiplication. 3 times 9 is 27. If this is x, x times x is x squared. What do we do to both sides? We take the square root. So x is the square root of 27. Or if you're using your TI calculator, it's going to give you 3 root 3. Okay, this last one, number 8, is a little more difficult, so you might want to talk to your teacher about it if you're not understanding this work right here. I've already written out the work. I paused and did it. But what I want you to see is that these 3 things right here, the only way we can get a proportion is to compare the hypotenuse of one triangle to the short leg of the same triangle. That's what I did. So I did hypotenuse of the smaller triangle, ST, is to the short leg of the smaller triangle, 6, as the hypotenuse of the largest triangle, right, which has a U in here somewhere, RU plus UT, so RU, we don't know, plus UT is 6, divided by the short leg, which is ST, which is 9. I did my cross multiplication, and you should get 7.5. Good luck.